Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
For this problem, we were looking at a race done at the Kentucky Derby. Now, for this race, we're going to compare the times of two different scenarios. The first scenario is one with a horse that starts at 16.58 meters per second when they come into the home stretch and has no acceleration, meaning it is running at a constant speed. That 16.58 meters per second is not changing, and it has 1,609 meters left in the race. The other scenario is one with a horse that's starting out at the same speed and is traveling the same distance, only this horse has a very minor but constant acceleration, 0.0105 meters per second squared. Now our goal is to determine what difference that acceleration is going to have in the time that each of these horses runs the race. So to do that, we need to pick our equation, and our equation is going to be the one that does not have that final velocity in it, because we do not know the final velocity for either of these cases, nor do we want to know. It's not what we're looking for in this problem. And that means we're going to be using this last equation here, x equals v naught t plus 1/2 at squared. Now, since our goal here is to find time, we're going to figure out pretty quickly that this equation is a nice and easy equation to work with for one of our scenarios, and a little bit less so for the other. So let's do our case with zero acceleration first. So switch back over to my colors here. X equals v naught t plus 1/2 at squared. When I plug in my numbers for this, we get 1,609 equals 16.58 multiplied by the time plus 1/2 at squared. And since the acceleration is 0, that whole term goes to 0, because whenever you multiply anything by 0, it just becomes 0. Now to finish this up, I'm going to divide both sides by 16.58. And we end up with a final answer, when there is no acceleration present, that the time spent running is 97 seconds. Okay, so that was pretty straightforward. We now just need to do that same equation, that same setup, for the acceleration case. So let's plug our numbers in there. We again have 1609 as our x value, 16.58 t plus 1/2 of that 0.0105, that very small but constant acceleration. And this number, we actually have to go through a few steps to reduce and make look nice. So we have 1609 equals 16.58 t plus 0.00525 t squared. Now I'm going to subtract that 1609 over to the same side, so I have 0 equals 0.00525 t squared. I'm rearranging things. The reason for that will become apparent in just a second, but just using some of our basic algebra rules, I am rearranging things here. 1609. And then I don't like that 0.00525 in front of the t, so I'm actually going to divide that out. Divide everything by 0.00525. And what we end up with is the equation that 0 is equal to t squared plus 3,158t minus 306,476. Now, this doesn't look like much of an answer, but for those of you who greatly enjoyed your algebra class, you will recognize this as a quadratic. And we have two options whenever we're looking at those sorts of situations. We can either try to factor it, good luck here, or we can jump to the quadratic equation. Because in that setup, we had an a value, a b value, and a c value. Let me write this out again. We had t squared t squared plus, we had t squared plus 3,158t minus 306,476. So my a value is the number in front of the t, which in this case is just going to be that 1. The b value is what we have in front of the t, and the c value is what we have in front of the c. So when I plug all that in, we end up with our answer being the opposite of b, so negative 3,158, plus or minus the square root of b squared, 3,158 squared, minus 4ac, so minus 4 times 1 times negative 306,476. Extend my square root a little bit, and that whole thing divided by 2 times a, which is just 2. So when we plug all this in and start working through some of the equations in your calculator there, we end up with x equals negative 3,158 plus or minus 3,346 divided by 2. Now, because we're talking about how long it takes the horse to run the race, we don't actually care about the negative 6,000 answer, because this horse can't run the race in negative 6,000 seconds. It has to be the positive value. So I'm actually just going to do the positive one here, which ends up with 188 over 2. And when we do 188 divided by 2, we end up with 94 seconds. So that's how long it takes the accelerating horse to move through it. So we have 94 seconds here for the accelerated motion. So what that ends up with is the difference in their times being 97 minus 94, meaning the horse that is accelerating will finish about 3 seconds ahead of the horse who is not accelerating.